Hello everyone, welcome to Module 3 of the Database Management Systems class. In this module, we will discuss the structured query language and advanced topics. Upon successful completion of this module, you will be able to create simple and compound queries in SQL for data manipulation, create a table using an SQL query, create computed fields in SQL to display specific information, apply built-in SQL functions, use subqueries in SQL, create a table using an SQL query, discuss entity, referential, and legal values integrity in relational databases, and use indexes to improve database performance. In Module 2, we discussed the relational model, query by example, and relational algebra. Query by example and relational algebra are approaches used to retrieve data from databases and to also manipulate the data. In this module, we will study the structure query language, or SQL. What is the structure query language? It is a data manipulation language which was developed for IBM in the mid-1970s. SQL is the standard language for relational database manipulation. It is used to create databases, retrieve data from databases, and also manipulate the data. SQL uses commands, and so unlike query by example, in which you complete an on-screen form, you must enter commands to obtain the desired results. It is also used by database managers and others to communicate with many different kinds of databases. Please note that though the examples in this module were created in Access 2016, you can, however, use Access 2007 or later to execute the SQL commands. To execute the SQL commands in Access, you need to open the SQL query window. To open the SQL query window, do the following. Open the BITS database, click on Create, click on the Create tab on the ribbon, click the Query Design button in the Queries group, click the Close button in the Show Table dialog box, click the View button arrow in the Results group on the Query Tools Design tab, then click SQL View. The Query 1 tab displays the query in SQL View, ready for you to type your SQL command. So let's go ahead and demonstrate how to open the SQL window in Access. So here I have the BITS database already open. So click on Create on the menu, click on Query Design, close the Show Table dialog box, click on View, and click on SQL. And of course, you have the Query 1 tab, which of course is displayed in SQL View, ready for you to type the SQL command. So if there are any commands to be typed, any SQL commands to be typed in Access, this is where you'll be required to do that. The SQL create table command creates a table by describing its layout, and that is the name of the table, the fields, the data types for each of the fields, and the field sizes. The field size or field length is the number of characters which can be contained in a field. The create table command is written as follows: create table, then table name, open parenthesis, field 1 and data type, the field length for the data type, comma, field 2, the data type for field 2, the field size for field 2, and so on until, of course, you've put in all of the fields needed for the table. The rules for naming tables and columns vary slightly from one version of SQL to another. It is a good practice to always consult the help application of the SQL version you are using. Common restrictions placed on table and column names by the database management systems are: names cannot exceed 18 characters. Names must start with a letter. Names can contain only letters, numbers, and underscores. Names cannot contain spaces. When creating a table, you must specify the type of data that the column can store, and in some cases, the length or field size for each column or field. Commonly used data types include integer or int, which stores integers which are numbers without a decimal point or decimal point. The content of the integer field can be used for calculations. Small int stores integers but uses less space than the integer data type, and the content can also be used for calculations. Decimal stores a decimal number p, number of digits long, with q, number of decimal places. For decimal, parenthesis 6, comma 4 represents a 6-digit number with 2 spaces to the left and 4 places to the right of the decimal. Note that some versions of Access do not have the decimal data type. The currency and number data types are used for fields that will contain currency values and for all other numerical values respectively. The char data type stores a character string n places long. The value for n must be an integer. The char data type is used for fields that contain letters and other special characters, and for fields that contain numbers which will not be used in calculations. The date data type stores dates in the form of date, month, and 4 digits of the year. The basic form of an SQL retrieval command is select from where. The fields to be displayed in the query results are listed in the select clause. After the word from, you may list the table or tables that contain data to be displayed in query results. The where clause, which is optional, lists any conditions or criteria to be applied to the data to be retrieved. A simple condition includes the field name, a comparison operator, and either another field name or a value. Please see pages 79 to 86 for additional information. Note that comparison operators or relational operators used in SQL are similar to those used in query by example and relational algebra. The conditions discussed and demonstrated so far are known as simple conditions. A compound condition is formed by connecting two or more simple conditions using one or both of the following operators: the AND operator and the OR operator. You can also precede a single condition with the NOT operator to negate a condition. When you connect simple conditions using AND operator, all of the simple conditions must be true for the compound condition to be true. When you connect simple conditions using the OR operator, any of the single conditions must be true for the compound condition to be true. Preceding a condition by NOT operator reverses the truth or falsity of the original condition. The between operator is inclusive. It includes the lower number, the higher number, and all the numbers in between. Please see pages 86 to 92 for additional information. You can include a computed field or a calculated field in queries. A computed field is a field whose values are derived from existing fields. Computing fields can involve addition, subtraction, multiplication, and division. Please see pages 92 to 94 of the textbook for additional information. Occasionally, when creating queries, exact matches may not work because you do not have complete information about a condition. For example, you might know only that the desired value contains a certain collection of characters. In such a situation, you will be required to use the like operator with a wildcard. In the SQL version of Access, the asterisk is used as a wildcard to represent any collection of characters, and the question mark is used to represent any individual character. The % sign is used as a wildcard for any collection of characters, and the underscore is used for any individual character in other versions of SQL. To use a wildcard, include the like operator in the where clause. Please see pages 95 to 97 of the textbook for additional information. This image or picture is what a select command with the like operator within the where clause looks like. You may recall that concerning the elements of a relation, the order of rows in a table is not important. So if the order of query results of a query is of significance, you should request that the data be displayed in a desired order. This process is known as sorting. In SQL, you sort data using the order by clause. The field on which to sort data is called the sort query. When sorting on two fields, the more important sort key is called the major, that is primary sort key, and the less important sort key is known as the minor or secondary sort key. Please see pages 98 to 100 of the textbook for additional information. This right here is an example of sorting data on two tables. In this example, the client limit field is the major sort key. So it is placed first, and the client name is the minor sort key. SQL also has built-in functions. Examples of SQL functions include the count function, which is used to calculate the number of entries in a given cell. The sum function, used to calculate the total of all entries in a given column. The average function, used to calculate the mean of all entries in a given column. The maximum function, used to determine the largest value in a given cell, or the highest value in a given cell. The minimum function, used to determine the smallest value in a given column. Please see pages 101 to 104 of the textbook for additional information. When it is valuable to obtain the results of a query in two stages, this can be achieved by placing one query within another. The inner query is known as the subquery, and it is evaluated first, and then the outer query is evaluated afterwards. See pages 104 to 105 of the textbook for additional information. This is an example of a query in which results are obtained in two stages. The select command for task ID is the inner or subquery. It is placed within the select command for order number. The process of creating groups of records that share a common characteristic is known as grouping. To indicate grouping in SQL, you use the group by clause. The order by clause is used to display the query result in a particular order. The having clause does to groups what the where clause does to rows. Please see pages 105 to 109 of the textbook for additional information. Queries can be used to retrieve data from more than one table. In SQL, the joining of tables is accompanied by entering the appropriate conditions in the where clause. To join tables, construct the SQL command as in the select clause, list all fields you want to display. In the from clause, list all tables involved in the query. In the where clause, give the condition that will restrict the data to be retrieved to only those rows from the two tables that match. When joining involves more than two tables, this is known as a complex join, and the procedure is essentially the same as that of joining two tables. Please see pages 110 to 114 of the textbook for additional information. As we discussed in Module 2, the union of two tables is a table containing all rows that are in the first table, all rows that are in the second table, or both tables. Note that the two tables involved in a union must have the same structure or must be union compatible That is, they must have the same number of fields and their corresponding fields must have the same data types. Please see pages 114 to 116 of the textbook for additional information. In addition to being used for creating tables and retrieving data from databases, SQL has many other important commands. These are the SQL update and set command, which are used to make changes to existing data. The insert command, used to add new data to a table. The delete command, used to delete data from the database. Please see pages 116 to 118 of the textbook for additional information. The results of a query can be saved as a table by including the into clause in the query. The into clause is written before the from and where clauses. Note that when creating a table from a query using Oracle SQL, you first of all create the new table using a create table command, and then use an insert command to insert the appropriate data into the new table. See pages 119 to 120 of the textbook for additional information. A view is an application program's or individual user's picture of the database. A view can be used to create reports, charts, and other objects. A view is less involved than the full database. The use of a view represents a great simplification. Views also provide a level of security. See pages 131 to 137 of the textbook. Views provide many advantages, such as data independence. And in views, each user has his or her own view. View should contain only fields required by the user. See page 138 of the textbook. The index is the main mechanism for increasing data retrieval efficiency in a relational database. It is conceptually similar to a book index. The index automatically assigns record numbers used by database management systems. The field or combination of fields on which index is built is called the index key. An advantage of the index is that it makes some data retrieval more efficient. A disadvantage of the index is the fact that the database management system must update the index whenever corresponding data in the database is updated. An index can be created on a field or fields when one or more of the following conditions are met. The field is the primary key of the table. The field is the foreign key in a relationship. The field will be frequently used as a sort field. You will need to frequently locate a record based on a value in this field. When an index whose key is a single field index is created, a single field index, which is also called a single column index, has been created. A multiple field index, also called a multiple column index or composite key, is an index with more than one key. See pages 138 to 141 of the textbook. Security is the prevention of unauthorized access to the database. The database administrator determines types of access various users can have. Some users may be able to retrieve and update anything in the database, while others may be able to retrieve any data from the database but not make changes to it. There are two SQL security mechanisms. One, the grant statement, which is the main mechanism for providing access to a database. The revoke statement removes privileges from users. See page 142 of the textbook. An integrity rule is a constraint put in place to prevent users from making errors when editing a database. A relational database must enforce two integrity rules. These rules were defined by Dr. Eve Code. The rules are: entity integrity is the rule that no field that is part of the primary key may accept null values. The referential integrity rule enforces the relationships established between the entities. See pages 142 to 147 of the textbook. Legal values integrity refers to a set of values allowable in a field. Legal values integrity is the property that states that no record can exist with a value in the field other than one of the legal values. See pages 147 to 148 of the textbook for additional detail. The database structure can be changed by adding and removing tables and fields, changing characteristics of existing fields, and creating and dropping indexes. Please see pages 148 to 151 of the textbook for more detail. In some cases, you may need to make changes that might not be allowed by your database management system. In these situations, you can use the create table command to describe the new table and then insert values into it using the insert command combined with a select clause. The select into command can create the new table in a single operation. See page 151 of the textbook for additional information. The system catalog, or simply catalog, contains information about tables in the database. It is maintained automatically by the database management system. Please read about the following topics: stored procedures and triggers, in pages 151 to 158 of the textbook. Activities to be completed throughout this week. Read chapter 3 of the textbook, that is pages 76 to 127. Read chapter 4 of the textbook, pages 131 to 158. Complete quiz 3. Complete assignment 3. Take part in discussion 3. Please take note of the due dates and plan accordingly.